In the next section of 5.4, we're looking at some applications for problems with exponential and logarithmic equations. So a common one is money. So in 5.1, we saw some equations. We didn't actually use them in our problems, but they were in section 5.1 of the textbook. So I just took these two snapshots from 5.1 since we didn't cover it in the notes for 5.1. So these are two equations that we use for interest. So here A is the amount of money you make after a certain amount of time. T is that amount of time in years. N is the number of times per year that that interest is compounded. And R is your rate as a decimal. If you have continuous compounding interest, then we can use this function over here where we use that irrational number e. And we still have r and t, but instead of the n, to have it compounded n times per year, if it's being compounded continuously, then we use e. And use this formula here. All right, so with these two formulas, here's your application problems for these. So we just have to identify those variables and then use that equation to find your answers. So for 83, if 7,500 is invested, that's our P. I forgot to mention that one. So the P, principal, that's the amount that's initially invested. So here our P is 7,500. Into a savings account, and it's earning 5%. So that's my rate, and I have to express that as a decimal. So 5% as a decimal, so you can divide by 100 and you get 0.05, so 5/100ths. And then we're compounding n times a year. Oh, sorry, wrong part. Compounding quarterly, that means 4 times per year. So n is 4. And we want to know how many years, so we need to find t, will pass until there is 20,000. So that's A is the total amount of money after a certain amount of time. So my A is 20,000. So that's setting up this equation. Now I'm going to plug all these numbers into this equation, and I get 20,000 equals the principal, 7,500, times 1 plus the rate over n, let's say 5, to the power of nt, so that's 4t, and I need to solve for t. And with the strategies from this section, 5.4, we can now solve for a variable that's in an exponent. So you used your log techniques. You're going to isolate the exponential equation. So that is this guy. You want to isolate this thing, dividing both sides by 7,500. And then you can take your log of both sides and get to that 4t, and then you can solve for 4t. So I'll leave that solving to you for your homework, but that's how we get it set up. So let's do that again with 84. Change our color to orange. Get some sun's colors on here. All right. So now let's read this again. So if 9,000 is invested, that's my principal. So my principal is 9,000. In a savings account earning 6%. So my rate is 0.06, rate as a decimal. Compounded continuously, which means we use this equation. How many years? So we need to find t will pass until there's 15,000 in there. So our total amount after that after however many years this is going to be 15,000. So I set up my equation. 15,000 equals the principal times e to the r t. And I need to use my log techniques to solve for t. So again, you isolate your exponential, and then you'll take the natural log of both sides and get that exponent out, and then you can solve for t. And I'll leave that one for you, both of those for you to solve for your homework.